So we have a situation wherein, let's read this, out of 15 managers, 5 are to be selected. In how many ways this can be done? If there is no restriction. If there is no restriction, we have 15, 5 of them have to be selected. This is selection. Using the word selection, there is no arrangement. The same question if it is told 5 are to be arranged out of 15. The moment it is a case of arranging, then it is going to be TR. So it will be 15 PR. 2 particular managers are always selected. So this is a case of included. So it is going to be 15 minus 2 C 5 minus 2. That means 2 out of 5 have already been selected and kept out. So 2 of them have been removed. The remaining 3 will be selected out of 15 minus the 2 who have been removed. So it's going to be 13 C3. So 2 particular managers are always selected in 13 C3 ways. 2 particular managers are never selected. That means out of the 15, 2 of them are already removed, but now the remaining 5 have to be selected out of 13 of them. So it's going to be 13C5. So 13C5 would be the case where it is 13C3 would be this, and 15C5 if there is no restriction. So this example, in summation, you can comparatively see the situation wherein a particular number of people are always selected or they are never selected. Hence we have this situation. This is an example which tells very effectively the difference between the 3 cases. Okay. Now we have, in how many ways out of 5 air hostesses and 6 pilots, 3 air hostesses and 2 pilots can be taken in a flight such that Mrs. Madhuri will not go if Sunil goes. That means if Sunil goes, Mrs. Madhuri will not go. But if Sunil does not go, Madhuri might go or still might not go. It is not sure. So Mrs. Madhuri will not go if Sunil goes. Right? So Sunil and Madhuri will never find in a single selection. So if Sunil is not there, Madhuri could be there or could not be there. So let's just list this down. So there are 6 pilots and 5 air hostesses. Among the pilots, you need to select 2 of them, and among the air hostesses, you need to select 3. So let's consider 2 cases. So Sunil definitely goes. So Sunil goes means Sunil has already been selected. So which means that 6 minus 1, Sunil, that is 5. So 5 are available for selection and only 1 has to be selected, 5P1. So that means Sunil goes, it means it is 5P1 into, now the air hostesses have to be chosen. So there are 5 air hostesses. Now the 3 will have to be chosen in, it won't be P1, it's a selection. So it's going to be 4C1. It is not a selection, so it's 4C1. Now, coming back to the air hostesses, now it is told that if Sunil goes, Mrs. Madhuri will not go. So if Mrs. Madhuri is out of these 5, but 3 have to be chosen out of in any case. So the case is when you have 5 air hostesses, out of which 1 is definitely not. So it's going to be 4C3. This is one possibility. The other possibility is Sunil does not go. So if Sunil does not go, it is a case of exclude for the males. That means out of the 6 pilots, Sunil is not going. So there are only 5 pilots left, but here we need to choose 2, both the male pilots out of the remaining pilots who are available, that is 5C2. And Madhuri may or may not go. So that means you have to select the 3 air hostesses out of 5, because here neither of them is excluded. So it's going to be 5C2 into 5C3. So let's understand this once more. 2 cases, Sunil goes. If Sunil goes, Sunil has already been kept aside. So out of the 2, only 1 has to be selected out of 6 minus 1, 5 pilots. But if Sunil goes, Madhuri does not go. That means we have to choose 3 of the air hostesses out of, we have 3 air hostesses who will have to be selected only out of 4 of them. So only 4 available. This is the case, first case. And Sunil does not go. If Sunil does not go, Madhuri might still go or might not go. So let's examine Sunil not going. That means out of the 6 pilots, 1 of them is out, but the 2 have to be selected out of the remaining 5. So in 5C2 ways, the remaining 3 air hostesses will have to be chosen out of 5 air hostesses. Now let's see what this turns out to be. It's going to be 5 factorial upon 1 factorial into 4 factorial into 4 factorial upon 1 factorial into 3 factorial, which is 5 into 4, that is 5 into 4, 20, plus, because it is odd, it's going to be 5 factorial upon 2 factorial into 3 factorial into 5 factorial upon 2 factorial into 3 factorial, which should be 5 into 4 into 3 factorial upon 2 factorial into 3 factorial. This is again a repetition, so it will be again the same, into 10, 10 into 10, 100. So there are 20, and remember it's odd, so 100 ways or 20 ways, so totally there will be 120 ways in which this selection can be made. So we'll come across similar kind of cases again to brush up this kind of concept. Okay, so we have 120 ways in which selections. So remember this thing, Madhuri will not go if Sunil goes, definitely, but if Sunil does not go, we cannot consider the case of exclude or include here for Madhuri, because Madhuri may or may not go. So you need to select the 3 out of 5 air hostesses. So this is one place where you should take a little bit of care, right? So we have 120 ways in which the selection can be done. Furthermore, yes, so we have 120, all right. Now here we have a case wherein out of 7 gents and 4 ladies, a committee of 5 is to be formed. The number of committees says that each committee includes at least 1 lady. So there are 4 possibilities. So totally you need a committee of 5 could be formed. So which could mean it could be 1 lady and 4 gents, or 2 ladies and 3 gents, or out of 5 you have 3 ladies and 2 gents, so the total still remains 5, or out of 5 you have 4 ladies and 1 gent, and it's told at least 5. Now if it had been told there are 5 ladies, we have to consider one more possibility, but there are only 4 ladies, so hence they have to be chosen. So it should either this or this or this or this. So 5 have to be chosen out of 4 gents and 1 lady. Totally there are 7 gents, which in the first case you have to choose 7. Again it is choosing, not arranging. So 4 are to be chosen out of 7, and 1 has to be chosen out of 4 into 4C1, or is translated as 1. Or you have 3 gents, that is 3 have to be chosen out of 7 and 2 have to be chosen out of 4 ladies. Or 2 have to be chosen, 2 gents have to be chosen out of 7 and 3 have to be chosen out of 4. The number of ladies maximum is 4. And the last possibility is 1 male, that is 1 gent is chosen out of 7 and all the 4 ladies are chosen. So there is only one way in which that can be done. So that is 7C4 into 4C1. This turns out to be 7 factorial by 3 factorial into 4 factorial. This would be 4 factorial into 1 factorial into 3 factorial. And this would be 7 factorial upon 3 factorial into 4 factorial. This would be 4 factorial upon 2 factorial into 2 factorial. This would be 7 factorial, into 2 factorial into 7 minus 2, 5 factorial into 4 factorial into 3 factorial into 4 minus 3, 1 factorial. This would be 7, 1, 6, and this will be 4, 4 and 0. On this we need to simplify, and this will work out to be 7 into 6 into 5 into 4 factorial upon 3 factorial into 4, which will turn out to be 4. This will get cancelled with this, and this will turn out to be just 4. And this will turn out to be 7 into 5, 35 into 4, 140. And this would be again the same, which would be 35, and this is into 6, which will turn out to be this, and this would be 7 into 6 into 5 factorial upon 5 factorial into 2. This gets cancelled, so this becomes 21 into 4, and this would be 7 into 6 factorial, and this would be in any case 1. So that turns out to be 140, and this will turn out to be 210, and this will be 84 plus 7 plus 1, and this will turn out to be, what do we have here? We have 140 plus 210 plus 84 plus 7 plus 1, which works out to be 7 plus 1, 440 and 7. Sorry, I'm sorry, here there is no 1 involved. So there is no 1 involved. It is 7 into 1. It is 7 into 1. So that is just 7. So which will turn out to be 441. And among these we have this as the option. So remember, at least could mean either 1 lady or 2 ladies or 3 ladies or 4, or it could even be 5, but then available ladies are only 4. So there has to be minimum 1 gent in any case. So understand the difference between at least, and we'll come across cases wherein there will be at most also. So there are 441 such possibilities. So let's see. Yes, we do have it that way. Next. Okay, here we have a case wherein a committee of 3 ladies and 4 gents is to be formed out of 8 ladies, and if under normal condition it would have been 8C3 into 7C4 would be the number of committees that can be possible. But here we have a particular clause. Mrs. X refuses to serve in a committee in which Mr. Y is a member, which means Y and X will never be together. Wherever there is Y, X is definitely not going to be there. But if Y is not available, X may or may not be available. That is a different story. The number of such committees is what? So how do we take up this kind of a case? So a committee of 3 ladies. So there are 8 ladies and 7 gents. And we need to choose 3 ladies and 4 gents out of these. So here we have, in a normal condition, the clause would be, suppose there is no clause given, it would be 8C3 into 7C4. That will form the number of committees. But here we have a clause, Mrs. X refuses to serve in a committee in which Mr. Y is a member. So if Mr. Y is a member, Mrs. X is excluded. And if Mr. Y is not a member, Mrs. X may choose or may not choose. So as long as Mr. Y is around, X is definitely not in the committee. But if Y is not in the committee, Mrs. X may or may not. So let's consider the case wherein Y is a member. If Y is a member, that means Y has already been included. So that means we need to choose 6 out of 6 because Y is already included. So it's going to be N minus M, that is 7 minus 1, C R minus M, that is 4 minus 1, 3. That means since Y is already included, the remaining 3 have to be chosen out of 7 minus 1, 6. Now, once Y is a member, Mrs. X is not a member. So that means that 3 ladies have to be chosen out of 8 of minus 1, 7C3, which will turn out to be 7 factorial upon 3 factorial into 7 minus 3, 4 factorial into 6 factorial upon 3 factorial into 3 factorial. Suppose Y is not a member. Y is not a member means among the male members, Y is not a member, so the 4 have to be chosen out of 6. So it's going to be 6C4. 4 of the members, male members, have to be chosen out of 7 minus 1, 6. And if Y is not a member, so 3 of them will be now chosen out of 8, because Mrs. X may or may not be a member. So Mrs. X is not actually included in this case. She is neither excluded nor included. She may or may not choose. This turns out to be 8 factorial upon 3 factorial into 5 factorial into 6 factorial upon 2 factorial into 4. This will turn out to be 7 into 6 into 5 into 4 factorial upon 3 factorial into 4 factorial. This turns out to be 35 into 6 into 5 into 4 into 3 factorial upon 3 factorial into 3 factorial. This gets cancelled. This also gets cancelled. So it's 35 into 20, which turns out to be 700 here. And here what do we have? 8 into 7 into 6 into 5 factorial upon 3 factorial into 5 factorial. This gets cancelled, and hence it is 56 into 6 into 5 into 4 factorial upon 2 factorial into 4 factorial gets cancelled. That is 15. So it's 56 into 15. 56 into 15, 0, carries 975 plus 9, 840. So it's 700 plus 840, which will be 1540. So 1540 ways in which such committees can be made. So it is 1540 such committees can be made. So it's once again we consider 2 cases. Y is a member, which means you need to choose only 3 more members since Y is already included out of 6. And now X will definitely not choose to be part of the committee. So you need to choose all the 3 ladies out of 7. So this is one possibility. Suppose Y is not a member. That means Y is not in the panel of selection. So 4 have to be selected out of 7 minus 1, 6. X may or may not be a member. So the 3 ought to be chosen out of 8. So we have 8C3. And this works out to be 1540. So our correct option is 1540. And yes, we do have it that way. And we have the solution in this manner. What do we have as the next sum? Okay. So in how many ways a committee of 6 members can be formed from a group of 7 boys and 4 girls? So there are 7 boys and 4 girls. And a committee of 6 have to be formed, having at least 2 girls. So there could be 2 girls and 4 boys, or there could be 3 girls and 3 boys, or there could be all the 4 girls and only 2 boys. Beyond this is not possible because all the number of girls have been exhausted. So there are only 2 girls. There could be either 2 girls and 4 boys, or there could be 3 girls and 3 boys, or there could be 4 girls and 2 boys. We don't have any further possibilities. So now, hence, what are the possibilities? 7 boys have to be chosen out of 4 boys. It is chosen, not arrangement. If the question was arrangement, we will change it to 7P4. So it's going to be 7C4. And 2 girls have to be chosen out of 4. So it's 4C2. Or, so it's so it's going to be plus 3 boys are chosen out of 7. So it's 7C3. And 3 girls are chosen out of 4. That is 4C3. or, that is plus, 2 boys are chosen out of 7, so it's 7C2 into 4 are chosen out of 4. So this way. So this turns out to be 7 factorial by 3 factorial into 4 factorial. This will be 4 factorial upon 2 factorial into 2 factorial plus 7 factorial upon 3 factorial into 4 factorial into 4 factorial by 3 factorial into 1 factorial plus 7 factorial upon 2 factorial into 5 factorial. Now 4C4 in any case is 1. Now let's simplify this. It will turn out to be 7 into 6 into 5 into 4 factorial upon 3 factorial into 4 factorial. This gets cancelled. This also gets cancelled. 35. This will be 24 by 4, 6. So it's going to be 35 into 6, 210. Plus, this would be again the same thing, that is 7 upon 3 factorial into 4 factorial, also 35, into this would be 4 into 3 factorial by 3 factorial, that is 35 into 4, 140, plus 7 into 6 into 5 factorial upon 2 factorial into 5 factorial, that will be 42 plus 1, 21. So it will become 350 plus 21, 371 such possibilities we have. So 210 plus 140, 350. So 371 such possible committees can be formed, and the correct answer is 371. Let's verify this, and yes, we do have it that way. Okay. Furthermore, we have a case wherein a boy has 3 library tickets and 8 books of his interest in the library of these 8. He does not want to borrow Mathematics Part 2 unless Mathematics Part 1 is also borrowed. That means if Mathematics 2 is chosen, Mathematics 1 also has to be chosen. Okay. In how many ways can he choose? However, it doesn't mean that if Mathematics 1 is chosen, Mathematics 2 also has to be chosen. So, in how many ways can he choose the 3 books to be borrowed? So, one case is when Maths 1 and Maths 2 are borrowed, or Maths 1 not borrowed. Maths 1 is not borrowed. Yes, so not to borrow unless Maths 1 is also borrowed. So, or we have a case, So he does not want to borrow Mathematics Part 2 unless Mathematics Part 1 is also borrowed. So if Maths 2 is chosen, you need to choose Maths 1 also. So this is a case wherein Maths 1 and Maths 2 are already removed out of that. That is, 2 of the library tickets have been used to remove Maths 1 and Maths 2. That means 2 of the books are already chosen. So out of the remaining 6 of them, 1 has to be chosen because 2 of them have already been chosen. So it's going to be 6C1, or 1 of them is not chosen. So the other books, remaining 3, have to be now chosen out of 7. So 7C3 plus 6C1 is the way. So this turns out to be 6 factorial upon 5 factorial plus 7 factorial upon 3 factorial into 4 factorial, which would be 6 into 5 factorial upon 5 factorial, should be 6. 7 into 6 into 5 into 4 factorial upon 3 factorial into 4 factorial. This turns out to be 35 plus 6, 41 ways in which the book has to be borrowed. So I'll just explain this once more. So he has 3 library tickets, and in the library of these 8, there are totally 8 books, out of which 1 book is Mathematics 1, 1 book is Mathematics 2. He does not want to borrow Mathematics 2 unless Mathematics 1 is also borrowed. So, in how many ways can he choose the 3 books to be borrowed? So, one case is wherein he chooses Mathematics 1 and Mathematics 2 have already been chosen out of the 3 library tickets. So, he is left with only 1 library ticket. But also, since 2 books have been chosen, there are only 6 more books left. So, 1 has to be chosen out of 6 in this way. It's told that Mathematics Part 2, so whenever he borrows Mathematics Part 2, Mathematics 1 is borrowed. So, Mathematics 1, so here there is a thing, suppose Mathematics 2 is not borrowed, it should be Mathematics 2 is not borrowed, but if 2 is not borrowed, 1 can be borrowed, which means along with Mathematics 2, there has to be Mathematics 1, but along with Mathematics 1, there need not be Mathematics 2. So the second case is wherein he does not to borrow Mathematics 2. So he still can borrow Mathematics 1. And hence there is one book, Mathematics 2 has been excluded over here. So in that case, there are only 8 minus 1, 7 books, but he still can choose to borrow Mathematics 1. And hence the 3 library, all the 3 tickets that are there will be used to choose 3 books out of 8 minus 1, 7, and hence we have 7C3, and that works out to be 41. So be careful about this part, that if Mathematics 2 has to be borrowed, Mathematics 1 will also be borrowed. But if Mathematics 2 is not borrowed, Mathematics 1 can still continue to be borrowed. And hence we have 41 possibilities, 41 ways in which he can choose the 3 books. So our correct option is 41. And let's see what we have. Yes, we do have it as 41.